Praise the Lord, Janissa. How do you do? Yes, I'm meeting. The class is open, please.
Good evening, sir.
A very good evening, Janissa. Glad to see you. Today you look much fresher and much brighter. Yesterday you were a bit tired and exhausted. I'm very
Yes, sir.
happy that even at the 11th hour you are very active. I appreciate your enthusiasm. As usual, you are very consistent. Yeah. So yesterday I gave the homework that you read the solutions chapter. That is your textbook. I'm very sure you have gone through. I too have gone through. You know, Janissa, even for an experienced teacher like me, uh, needs reading, rereading, revision. So students require more, no? Because Janissa, I'm on a different level. I'm currently in more into research, but aunt insisted me that I should take lectures for you. I should teach classes to you. I cannot deny anything that comes from aunt. So because of the compulsion and because of the obligation I had with aunt, I'm taking the classes for you, and it will continue. It will continue until we successfully complete all the 10 units. Initially, the classes have been a bit slower. With the time, the rate at which we discuss the various important aspects in each of the 10 chapters will be much faster, because I'm very sure you are having the gift of grasping power. You grasp very quickly. I have seen you are much faster than me in watching the screen and understanding what is happening in the screen and when the lecture is going to be closed. Okay, for today we have only 40 minutes time, Janissa. I did not generate the second link. Okay, this 40 minutes we'll use effectively. With time, we'll increase to 40 plus 40, 80 minutes. Okay, because I'm very sure you have other branches of science also that you need to read, like mathematics, physics, engineering, and design, and one more thing that you have told, physical education. All those things require time and effort. Okay, yesterday we were at one point, we were discussing about the way in which we can express the concentration of solutions, because that is very much related to day-to-day life, practical applications, industrial applications. When we tell or talk about solutions, we should always define the solutions in terms of concentration. And I told you there are various ways of expressing the concentration. Am I clear, Janissa? Is my voice audible? There are various ways of expressing the concentration, ranging from molarity, molality, normality, parts per million, then weight percent, mole percent. These are all available, but Janisa, chemists prefer one or two methods, not all. Usually at higher levels, we use molarity. Huh? That is a normal way of expressing concentration. For regular day-to-day life, we express in terms of weight percent. For example, antifreeze agents. Can you name some antifreeze agent that is discussed in chapter 1, unit 1, solutions? Ethylene glycol. Ethylene glycol is called antifreeze agent because it reduces the freezing point of water from 0 to some minus 17.5 degrees centigrade. When the freezing point of water itself is lowered, what will happen is, the engine performs better. The engine, for cooling the engine, for reducing the freezing point, freezing temperatures of water, especially in cold countries, this antifreeze agent like ethylene glycol is very much used. So what is the typical concentration of antifreeze agent ethylene glycol in engine applications? 35 weight percent. We are dealing with concentration. 35 weight percent means what? In a typical solution, 35 grams will be ethylene glycol, and the rest of 65 grams will be water or some other solvent, aqueous or non-aqueous. In this particular application, water. Okay, this is the way we express concentration in terms of weight percent or mass percent. Yesterday, Aunt has shared with me the material that was provided by Velamal College teacher, and it's a very good material. I will quickly recap the material. There is some small correction that I want to show to you. Both your teacher and myself did small error. I want to bring to you how even teachers can do mistakes and how students should be much smarter than we teachers. Janisa, it doesn't mean that your teacher do not know mathematics when your teacher does some mistake with calculation. It doesn't mean that I do not know molality when I do some mistake with molality calculation. We are, at a different level, we are not into truly in your shoes. Okay, so even though we do minor mistakes, it is permitted because, we are not really into that. Your primary task is to learn to verify if the material given to you is correct or not. I'm doing that. I'm carefully scanning through the material that has been given to you, and if there are any needed corrections, I'm incorporating. What I mean to say is you should not take anybody as gospel truth. Nobody is Jesus Christ, okay? Nobody is Holy Spirit. We are human beings and we are prone to errors. And what I mean to say is from my mistakes, you should learn. From my mistakes, you should say, sir, this can be the other way. Probably you are wrong. This is the correct way. I expect that correction. Okay, ma? I'll show you one simple mistake both your teacher and myself did. So that, you should be smart enough to identify the mistake and you should not repeat the mistake. Understand? Yeah. I thought molarity, normality, ppm, all these to many students while I was, into the teaching. But, for past 1 year, I am not really into the teaching. I am at a higher level of research and more into writing research papers. Of course, fundamentals are very important. All the building structure will be strong provided the foundation is well. This is the foundation on which we build research. It doesn't mean that the foundations are not necessary when we go up in the ladder. But what I mean to say is molality. We really do not use molality in day-to-day life. We really do not use molality in calculations of preparation of solutions in the laboratory. So there is a chance that even an experienced researcher like me go and do error. You should be pointing out, sir, probably you're wrong. Okay, I'll just show you one mistake that has been done both by your teacher and myself. What I mean to say is that teachers are much above students. If they do some mistake, you should not think that they do not know anything. These days, the current generation of students are of the opinion that if by some reason, if the teacher does some error, they come immediately to a conclusion that the teacher doesn't know anything. It's not, it should not be the way. Okay, first, let me open the material that Aunt has given me. The material that Velamal College has provided you for a quick revision. You see how well I am organized, Janissa, from dawn to dusk. I really will not have breathtaking time, but still, I am obliged to listen to what Aunt has said, and I will continue until I finish the curriculum. Okay. Initially, the classes will be a bit slower. With time, I will try to be as fast as possible so that the curriculum can be completed before the start of the exams, that is February 15th. What I mean to say is, I'm looking for the notes that Aunt has sent me. This is copy. I put it in a different, edited. You see how well I'm organized. Janissa, I sent some 20 old question papers. Did you get the old question papers in WhatsApp?
My grandmom didn't show that.
Yeah, I sent to Aunt's WhatsApp. Please go through the question papers. That is the intention with which I am sending. Okay, so what I request you to do is, you have to, fortunately, the question papers that I sent to you are not divided of answers. They have the questions, they have the answers. That is the homework. Each day, at least you should solve one question paper. You try to answer the questions. Okay. And if you find something difficult, answers are already there at the end. If you find something difficult to your comprehension, you can always discuss with me. Sir, 2025 paper number 10. Open that. I'll open here. And if you find any answer, the solution, not understandable to you, if you think that there is an error, we'll analyze together, we will relook together and try to understand the answer. I may not be able to deal all the question papers, but still I encourage you, at least one question paper you should solve. Emma, that is how you can be thoroughly prepared for the exam. We are hardly spending 40 minutes. Okay, next week we will spend the 40 plus 40, 80 minutes. But still, that is not sufficient because 10 chapters we have to complete in 20 days. It's a Herculean task. Okay, let me open this. Okay. Yeah, this is the material that Velamal College staff has provided you. You see, Amma, the question is like this. Can you read the second question, please?
Calculate the mass of urea required in making 2.5 kgs of 0.25 molar aqueous solution.
Very good question. What is the concentration unit that is used in this issue, in this problem?
Molal.
Molality. How does molality differs from molarity? Molarity we use capital M as symbol. Molality we use small m. Okay, ma. Molality is defined like this. Number of moles of solute per 1 kilogram of solvent. Repeat. What is molality? Number of moles of solute. Tell me.
Solute.
Molality is
number of moles of solute per 1 kilogram of solvent.
Solvent. Again, molality is, repeat with me.
Number of moles of solute per 1 kilogram of solvent.
Solvent. It is very important. It's not solution. When you talk of molarity, capital M, it is 1 liter of solution, not solvent. It's like weight percent. It's like weight percent. Here, it's solvent. So that is the difference, Amma. As you can see here, after defining molality, number of moles of solute per a kilogram of solvent, we have to identify how much urea is required to prepare 2.5 kg 0.25 molar solution. That is the question that is asked. Okay, ma. For that, you should know something about moles. Okay. Moles means number of moles is equal to weight by molecular weight. When we number of moles is equal to weight by molecular weight. So the number of moles of urea that is present in this problem is 0.25 moles. Okay, ma. From this, here urea mass of solvent, it is written as mass of solvent. It's not solvent, you know. Urea is solute. Okay, aqueous solution. So you should be able to differentiate between what is solute and what is solvent. Urea is not solvent, even though it is written as a solvent. Okay, ma. So what is the solvent here? Water. Because in a system, the major amount, what is the major amount? What is the major component? That is what is called solvent. In this case, the major component is not urea. The major component is water. So water is the solvent and urea is the solute. So mass of solute, it should be present as mass of solute is equal to 60 grams per mole. Even not mass. It should be written as molecular weight. Molecular weight of urea solute is 60 gram per mole. Molecular weight is often expressed in the units of gram per mole. Okay. So from molecular weight, we can get the weight by number of moles is equal to weight by molecular weight. I'll write here. Yeah. Number of moles is equal to weight by molecular weight. Okay, we have to identify weight of urea. Okay, so weight of urea is equal to number of moles multiplied by molecular weight. This is number of moles 0.25 and molecular weight of solute is 60. 60 multiplied by 0.25 is 15 grams. Okay, so 15 grams, I'll write here. 15 grams urea solute in molal. Molality means 15 grams of solute is present in
1 liter.
1 kg
Okay,
of
1 kg.
water. Solvent. Water is the solvent. Okay. How many grams of urea solute will be required for preparing 2500 grams 2.5 kg means 2500 grams aqueous solution. So cross multiplication. X is the amount of urea required to prepare 2.5 kgs of 0.25 molal solution. So X is equal to, by cross multiplying, what will happen? 15 into 2500 divided by 1000. Okay. So 0, 0, 0, 0. 15 multiplied by 2.5. 15 multiplied by 2.5. Okay. 15 to is 30 and half of 15 is 7.5. 37.5 grams. Okay, ma. Even here, if you can see here, maybe, yeah. Mass of solution is 1000 grams of water plus 15 grams of urea. Total mass is 1.015 kgs. Okay. 1.015 kg urea solution contains 15 grams. 2.5 kgs contains how much? Here too, you know, I2, here the cross multiplication is a bit problematic, you see. 1.015 kg urea solution contains 15 gram urea. How many? 2.5 kg urea solution require how many grams urea? So 2.5 into 15, 2.5 into 15 divided by 1.015. Yeah, you see, it's not 15 divided by 1.015 into 2.5. This is wrong. The multiplication should be 2.5 into 15 divided by 1.015. Then you will get 37 grams. Okay, ma? 37 grams is correct. This is wrong. This is wrong. 37 grams is correct. It will be somewhere around 36. Can you multiply? If you have calculator, can you please multiply and see what is the value of 2.5 multiplied by 15 divided by 1.015?
I'm doing, sir.
Yeah. If you have calculator, please do, Amma. 2.5 multiplied by 15 divided by 1.015, how much it is? 36 point
2.5.
multiplied by 15
Okay.
divided by 1.015.
36.9.
Yeah, this is the correct answer. Okay, ma. 36.9 grams urea. 36.9 gram urea is required to prepare 0.25 molal 2.5 kg aqueous solution. Even this is how I did a mistake. It's not 37.5. 36.9 is correct. The answer that your teacher has shown is correct, but the mathematical calculation here doesn't give 36.9. Okay, can you please calculate 1.5 divided by, one more calculation please. 1.5 divided by, sorry, 15 divided by, Janisa, are you able to follow?
Yes, sir. 15 divided by
1.015.
1 minute, sir. 1.015.
Yeah, how much?
1 minute. 14.7.
Exactly. Again, divide this value by 2.5.
5.9.
You know, if this mathematical expression were to be used, 15 divided by 1.015 into 2.5, we should arrive at 5.9. But the answer is close to 37. How did we get 37? 2.5 cross multiplied by 15 divided by 1.015. That is how it should arrive at 36.9 grams. Okay, ma? So this is the slight error here, and this is the mistake in my calculation. So from the errors of others, we should learn. Followed? That is why I say, even the material that is given by teachers, you should take it with a pinch of salt. You should take that with a pinch of salt, because the teachers may commit error and mistake. Okay. Let us move forward and coming back here, what I want to show is, yeah. Yes, Janisa, are you with me, Amma? Are you able to
Yes,
follow?
sir. Yes, sir.
Yeah. There are various ways of expressing concentrations. We have discussed them in detail. Yesterday, what else we discussed, Amma? Can you recap in yesterday lecture? What is the major fraction? Major.
Colligate property.
Very good. Excellent. Colligative properties we have discussed. What are the various colligative properties that we discussed?
Relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure.
Excellent. Excellent. Uh, Relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. What is the symbol for osmotic pressure? Pi. Pi is the
Pi.
symbol for osmotic pressure. Partial pressure, what is the symbol? Small p. Capital
P.
pressure, what is the symbol? Capital P. Okay. Total pressure. Total pressure is different from partial pressure. Because, Janisa, I am there, aunt is there. Okay. I am putting 10 kilo pressure on you. Aunt is putting 20 kilos pressure on you. Okay. What is the total pressure that is on you from me and aunt together?
30.
Yeah, that is what is called total pressure. There are two components that are working on you. Simultaneously, I am putting 10 kg pressure. Aunt is putting 20 kgs pressure. How can you withstand? And that is good because the amount of gas that is solubilized in a solvent is proportional to pressure. If there is no pressure, the subject of chemistry will not go into your mind because pressure and concentration are proportional. This is Henry's law. As far as the Henry's law is concerned, greater the pressure, greater will be the solute that is solubilized in solvent. Aunt is putting 20 kg pressure, I am putting 10 kg pressure. These are called partial pressures because we are two components. P1, me, P2, aunt. Okay, P1 plus P2 together is 30 kgs. This is what is called total pressure. Of course, pressure is expressed not in kilograms. Pressure is expressed in terms of atmospheres. Pressure is expressed in terms of pascals. Pressure is expressed in terms of bar. Pressure is not expressed in kilograms. Only weight is expressed in kilograms. Just for your understanding, I'm telling. Okay, because you have a feel of what 10 kgs look like. You do not know what 1 atmosphere look like, even though you always feel atmospheric pressure. Okay. Even though you always feel atmospheric pressure, you really cannot understand what 1 atmosphere is or what 1.013 bar is or what the pascals means. That is why I told in terms of weight, if I put 10 kilograms of books on your head, aunt puts 20 kilograms of books on your head, we think that at least 5 kilogram will go into your brain. That is Henry's law. We cannot do anything with that. We are following Henry's law. After that, you will realize, after the end of the exam, you will think that aunt is indeed a precious, care taking person. Aunt is really, caring for you. I am caring for you. Now, you think that we are pressurizing you. We are not allowing you to go through what, rest or some kind of, recreation or entertainment that you want to do. These kinds of things are very much necessary. That is why we are, making you to revise, re-revise, study. Okay, ma. Henry's law. Henry's law is, pressure exerted on a gas by a solvent, solute is proportional to concentration of solute in the solution. Likewise, osmotic pressure. Osmotic pressure is also same. Pi is proportional to concentration. Okay, ma. Then Raoult's law. Raoult's law is relative lowering of vapor pressure is proportional to mole fraction of solute. Okay, P naught minus P1 by P naught is proportional to X2, mole fraction of solute. Okay, based on that, we calculate the molecular weight of the solute, that is non-volatile solute. Volatile solute is different, non-volatile solute is different. Okay, ma? Non-volatile solute means that will not get vaporized. For example, camphor. Camphor is volatile solute. Okay, naphthalene is volatile. Whereas glucose, can you understand the difference between glucose and camphor? Do you understand the difference between glucose and naphthalene? If you put naphthalene on the table, if you put sugar on the table, by tomorrow morning, the naphthalene ball size will decrease. Whereas the amount of sugar that you have put on the table will remain as it is, because one is volatile solid, other is non-volatile solid. Likewise, if you put water and acetone, the vapor pressure, based on the difference in the vapor pressures, difference in the boiling points, the change in volume you will observe. Okay, moving forward, what I want to discuss today is more on the problem solving. Okay, Janissa, we have to follow the exam question paper pattern. As I told you, we have 1 mark questions 16, 2 marks questions 5, 3 marks questions 7, and 5 marks questions 3, and 4 mark questions 2. Am I correct? Yeah, so there will be internal choice in some cases, and you should choose the best questions that you know. Let us move forward and do some problems, Sama. Solving problems is very much necessary. I told you an example, okay? Antifreeze agent. Typical concentration of antifreeze agent is 35% ethylene glycol. Likewise, typical concentration of dissolved oxygen in seawater is 5.8 ppm. What is ppm? Parts per million. When the concentration of the species of the solute is so low, then you call it, you express the concentration of the component in terms of parts per million. Parts per million is defined like this: parts of the component, parts of a particular component in a solution divided by total parts of all the components multiplied by 10 power 6. Okay, this is what is called ppm. ppm can also be expressed in terms of microgram. ppm can also be expressed as, yeah, some small sounds will distort me. You see, ppm can also be expressed as microgram per ml or gram per liter. Do you see, Amma? ppm is how many micrograms is present in 1 ml. To that small level also we can measure the concentration. Nowadays, nanotechnology is there, even nanogram. Nano means 10 power minus 9 grams of analyte in 1 ml. That is what is called ppm. After that, ppb we have. Let us see other expressions of concentrations. Mole fraction. Mole fraction is very important. Mole fraction is mole fraction of a particular component. For example, we have a 2-component system. Sugar in water, ethanol in water. Sugar in water, if you have 10 grams of sugar, glucose in a solution of 100 ml, what is the solute? Glucose is the solute and water is the solvent. And then we have 2 components and we have to express the concentration of the solution in terms of moles. Okay, mole fraction of glucose, mole fraction of water. Okay, ma. Let us see how to express that. Okay. Usually, mole fraction is represented in the letter X. The symbol for mole fraction is X. Mole fraction of A, if we have 2 components, for example, glucose, and glucose is called as A and water is called as B. Okay, mole fraction is number of moles of component A divided by number of moles of component A plus number of moles of component B. Again, I told you number of moles means weight of glucose divided by molecular weight. What is the molecular weight of glucose? 180 grams. If you have 10% of glucose solution, 10 grams of glucose in okay, 100 ml of solution. What is the number of moles of glucose? 10 by molecular weight is 180. This is the number of moles of glucose, Ng. This can also be written as 1 by 18. Likewise, number of moles of water is equal to amount of water divided by molecular weight of water. 90 by, okay, 18. Now, to express the mole fraction of XA means mole fraction of glucose in water. Ng by Ng plus NW. So 1 by 18 divided by 1 by 18 plus 90 by 18. Okay. So 1 by 18 into 18 by 18 plus 90 into 18. Okay. 18 gets cancelled. 1 by 18 plus 90 into 18. Janisa, can you please calculate amount? How much is 90 into 18? 90 by 18?
90 by
90 multiplied by 18. 180 into 9 or 180 into 9. 180 multiplied by 9.
1620.
Excellent. Okay. 1620 plus 18 is 1 by 1638. Okay. 1 divided by 1638. 1 divided by 1638.
0.00061050.
0.00.
0.0006105.
Okay. This much low. Did we do some mistake? Usually this is how we will calculate the mole fraction amount. Number of moles of solute divided by number of moles of solute plus solvent together gives mole fraction of solute. Okay. Yeah, we did a mistake. 1 by 18 into LCM is 18 only. Okay. Least common multiplier is 18. So it will be 91. It will be 91. 1 by 91. That's all. Can you please divide it? 1 by 91? There is something called least common multiplier. Okay, ma? Okay. Can you please calculate what is 1 by 91? 1 divided by 91?
0.0109.
0.0109. Okay. Probably this should be the correct answer. This is how usually we calculate the mole fraction. If we have two components, this is how we calculate the mole fraction. If we have multiple components, the mole fraction of each component can be the mole fraction of each of the components can be calculated using this equation. Moving forward, let us see this solution. Calculate the mole fraction of ethylene glycol. The formula of ethylene glycol is CH2OH, CH2OH, CC bond will be there. The ethylene glycol molecular weight is 62 grams, and calculate the mole fraction of ethylene glycol in aqueous solution. So how many components are there? Two components. One is ethylene glycol, other is water. Okay. In ethylene glycol solution, what is the solution and what is the solvent? Ethylene glycol is the solute and water is the solvent. What is the composition? What is the concentration of the solution? 20% ethylene glycol means 20 grams ethylene glycol in 100 grams of solution. 20 grams of ethylene glycol plus 80 grams of water. Okay, from this, how to calculate the mole fraction of ethylene glycol? Mole fraction of ethylene glycol is equal to, okay, number of moles of ethylene glycol divided by number of moles of ethylene glycol plus number of moles of water. Number of moles of ethylene glycol, how will we get? Weight of ethylene glycol by molecular weight of ethylene glycol, 20 divided by 62 divided by number of moles of ethylene glycol is 20 by 62 plus what? Water number of moles can be calculated by weight by molecular weight. What is the weight of water? 80 divided by, what is the molecular weight of water? 18. Okay, so 20 divided by 68. Okay, 20 divided by 68 whole divided by 20 by 68 plus 80.
So 62.
So it is 0.068. Okay, ma. It's the